Hello? Is this thing on? Hello, hello? How is everyone? Make sure all my audio is good. Okie dokie. No memory card. Yeah. Do-do-do-do-do. Okie dokie. Yo, what up? Let's get some food going. I don't want to mess with the jumper list a little bit today because, yeah, the guy who made it, Kevin, added some code in there to let us use the Raspberry Pi PIO, programmable I/O cores, and those are important because you can write little assembly programs for them that run kind of independently in their own little world, so to say, and they have pretty quick response times, so we can use them for really fast switching. And I want to potentially test that out with the scope and see how fast I can get it to switch, and maybe we can use it for glitching, some hardware glitching stuff. So I might mess around with that a little bit later. Get the stream URL. I think. And I just want that part. I think ACM2 will do it. Let's see. Yeah. Just to double check. Oh. Nice. Alright, so what I was doing last is I was, as a viewer suggested, I should probably just be doing all this in the PCB editor anyway. Which is kind of what I knew in the back of my mind for the longest time I was doing this, but, so I started that. I started messing around with that, and I've gotten a little bit more familiar with the interface. I've got some stuff laid out and routed. So we can see we've got like the back side of the board and the front side of the board. And I went through and resized and rescaled these images and got them in here aligned with the components. I have to do some adjustments with a lot of these parts because the standard sizes, I guess, are not standard anymore. Because this was built in the 70s, this calculator. So as you can see, like the traces are all wibbly wobbly. They're not very angular or anything like that. So trying to build these out is kind of interesting because you have to like account for differences in like modern PCB design versus old school PCB design. But anyway, I'm trying to get this connector plotted out with a part, so I'm working on the footprint for that thing. It's a 2x10 connector, right? 1, 2, 3, 4, 5, yeah. So I've taken the existing 2x10 pin socket footprint, and I'm going to change the pitch on that to 3mm instead of the 2.54. And hopefully that'll give me what I need. If I go like measure from here to here. Oops. Bro, where'd you go? Shift. Yeah, it's about 3mm, so I'm going to change the pitch of this to 3mm and then get that on here. How I'm going to do that, I don't really know, so we'll find out. So, I don't know. I'm guessing these are made with, like the array tool or something. I don't know if I just need to, like, shift everything down. Because it's, 2.54mm. I had, what, 0.46mm, and then give me 3. I guess we can start with, let's just try. Is it 2.45? What did I say? Shit. 2.54. I need 46.46. Alright, don't forget that. Oops, other way. Okay, so if I measure this, okay, so now that's 3. I feel like there's probably a better way to do that programmatically. Can I just set the user grid to 3mm and then snap them all to that? Maybe? That'd be easier. So if I Control Shift M, measure from here to no. Oh, are they even going to center on the 3mm dots? Grids? I don't know. I do... At 3mm? No. Yeah, I think it's probably easier to just resize it based off of the rest of them. We can look that up. Rays can't be parametrically edited in KiCad. Yeah, I think I might try that. Let's do this. Delete these. Nope. Why is this damn thing snapping to that? Oh, okay. Did have one. Wow, incredible. Let's do some more reading. I don't see special tools. Hmm. Ow, okay. Maybe there isn't an easy way to do that. Or maybe it's only in, because I saw it somewhere. Where you can arrange things in an array. Make an array from something. Is it in a symbol editor? I don't know. Or the schematic editor? Huh. No idea. Alright, well then how can I move these in a way that not collapse my brain? Oh, there it is. Create from selection. Okay. Deploy. Let's try this again. Oh shit, what is the horizontal spacing? Just do 3, right? Or here, I'll just measure real quick. Three, 7, 3, 2. Just do 3. Alright, let's see what this does. It'll probably mess it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. No? Did I do it? Huh. I think that might work. Wait, then you just draw a box around it? Come on, deselect it. Thank you. Actually, you know what? Let's just do that. Move this sucker up. And then we will draw a box. There, is that good enough? So then I come into here, add custom, do that. Nope. Is it not 3? Is it like 3.2 millimeters? Oh, yeah, I guess 3.2 does it. Sure. All right. Alright, turn my music back on. Okie dokie. Oh, I needed to make a footprint for the resistor network as well. Let's see. Oh, so I found a better way to start. You can open up the part that you want, the footprint that you want. You can come to your custom library, right-click, and hit Paste Footprint. Oops, why did I do that? That's not what I wanted, sorry. Straight lying. Delete footprint, yes. Where'd it go? IP8. That's what you do. You right-click, hit Copy Footprint. You don't have to open it. And you come over here, Paste Footprint. Name. I don't understand what these inner lines are. Type drawing shape segment. Layer fab. Oh, layer silkscreen. Okay, so they're for different layers. This purple is courtyard. Whatever that is. Are these 8? 1, 2, 3, 4, 5, 6, 7, 8. Plus the common ground. So maybe these aren't what we need. R_array. We need this one. Copy footprint. There we go. Now we can stick this sucker in the center. So first off, let's go ahead and move this. Move all of these. Not the reference. All of those over, and then move this guy right back into the middle, like so. Right, so if I hide the silk screen and just look at the mask, right? So the mask? No. Recall it, which one was this? Fab. F-Fab. Am I blind? Is it an object? No. Oh, there it is. I'm blind. Blam, blam, blam. Okay. Let's turn back on our silk screen. That looks good, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Blammo. Custom footprint. I'm gonna come back over here. And we're probably gonna have to change the distance or the pitch between these, but who cares? Go ahead and add our SIP9 center common. Look at the backside of this. No way. We don't have to change our pitch. You've got to be shitting me. I don't know why it takes so long for it to save. Probably because this computer is very, old. Okay, there we go. We place these everywhere else now, too. I actually use quite a bit on this board. I think that's all of them. Oh, where'd you go? Nice. Cool. Cool, cool, cool. Tight, tight, tight. What are we gonna do these? Guess we could, I was just using through holes for those, I guess, or vias. Right, that would be a via right there. That's a via. You can kind of see where there's like an indentation in the solder. Alright, let's finish wiring up this clock circuit. I don't think I have these pins connected. Go back to Krita. Let's see where those are going. Worry about this top one right here. That's going up here to VGG. Guys, going up to VGG. This thing actually does a weird fucky wucky squiggly thing. Is there a hotkey for brake track? There has to be, right? Oops. That's the real brake track button. There we go. Kind of snakes through there. It's weird. Alright, let me double check. Yep. That's strange, but okay. Yeah, so if we go look at the top, it kind of goes and it skips past this pin. There's a leg right here. And it kind of avoids. I guess you can line this up with that, right? Yeah, this board is real squiggly. Okay, and then this is also coming down to so bit of a mess. And then this emitter, oh, no, that's the ground, or the base, sorry. This base pin goes nowhere on the top, everywhere on the bottom. All right. Okay, I've already got this one. Oh yeah, that's this doohickey right here. Okay, cool. All right. What else we got connected on the back? Nothing? Okay. I mean, it's probably honestly the easiest to just go around and connect everything up on the back. Just because you can see those traces easily. So if I come over here to schematic and say, where's our clock circuit over here? And I name this resistor R1. So, which one is it? R1, this guy. Right here. Oh no. What have I done? PCB with changes made to schematic. Oh wait, annotated schematic. Interesting. Can I come back here and update PCB and board editor? Schematic symbol reference designators. What did that do? Wait a minute. I have no idea what that just did. Oh. What did that do? Okay, I have no idea what I'm doing. Okay, well, I will just start to number these, right? R1. I don't know if that's a good idea or bad idea. I should figure that out. Oh, so we can give it a footprint. Okay. So if I come in here and say double click on R1, I can set a footprint for it. Custom. Read this doohickey right here. Now these are all going to be different though, so... An assignment tool. Wow, okay. Hey, Pingu Fan. How's it going? Oh, see, I haven't gotten to that point yet. I haven't given up yet. There's plenty of other things that I've done that to, though. Are you saying third time will hopefully be the charm for giving up again? For a third time? I think I can come in here and copy this one and just get across all of these resistors, right? Paste? Oh, hell yeah. Is that not working? Okay. I don't think it likes to update that. That's okay. Alright. Gonna take 6 hours to save because for some reason... Actually, no, I guess it only does that with the PCB viewer or PCB editor. Custom axial vertical footprint. Sweet. I want to change these values to tools. There's a thing to let me change values or something. Oh, is it this one? Symbol reference designators. Oh, no, wait. That's not what I want. This thing, right? Bulk edit fields, walls, symbols, and schematic. Hell yeah. I hope so too. And I feel like that's one of the biggest struggles with like self-teaching or like learning stuff in general is just sticking with it long enough for it to kind of, I don't know, leave some residue behind. And I figure, at least with my method of learning where I just kind of throw myself at it enough times, eventually that residue starts to kind of pile up and you start to know a couple things. So hopefully your residue starts to pile up, so to say. That residual knowledge that you gain every time you go in there and start messing around with it again. Eventually you'll, like you said, do something useful with it. I'm kind of that way with designing models for 3D printing. I do very, very simple and basic things, but I don't know enough to get myself into like a really crazy model. Okay, I gotta confirm, are these actually 33K or are they 3.3K? I'm pretty sure they're 3.3K, or, sorry, 33K. Let me just double check. So these over here in the clock circuit, we've got orange, 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 I believe. Yeah, 33. And then 1,000. Okay. That's good to know, Z-Brad. It's good to know, because I have zero experience with all of the other tools, so this is my first foray into like PCB design software. I guess it's short for what, electronic design applications? These are 33. I'll go through and mess with the actual values later. These are all just generics at the moment anyway, so. I'm honestly enjoying KiCad. It's got a lot to it, but it's not extremely obtuse. Like there's some software that I've used where it has a lot of features and functionality, but it's really obtuse and hard to get at. I would say Krita is a lot like that. If you're familiar with like other Photoshop-like tools or just Photoshop in general, Krita has all of this stuff, but it's in just like kind of a, I don't know, weird, less obvious way if you're used to other tools, I guess. It's still really good. It's super powerful. I need to connect this dude because this is part of the clock circuit. Alright, what else do we have that's part of this clock circuit? I don't think I have this connected anywhere, do I? This goes, I think, to pin 20. Let me double check. Oh, no, wait, that's right. It goes, like, all the way over to this one, right? I think. Yeah, R6 goes over here. That fourth pin from the edge. This guy right here? Wait, this guy. And the lines on this board are so organic. I could nitpick and like try to get these things like curvy and organic like they are. IRL. I don't know if that's actually worth it or not, but it's fun, I guess. Alright, so that dude's hooked up. I think that's about all for our clock circuit. Who am I kidding? There's probably more that I haven't wired up, like this capacitor. No? Got him wired up. You're going to, what is it, pin 19? I think so. Oh, I've already got this one mapped out. That R5. Oh, that's right, you go all the way over there. Third from the right. Complete opposite side. doohickey. Coming from over here, right? Oh no, that's coming from this pin, I think. I can kind of see through the board. Okay. I think that's it for the clock circuit. Just save it. It's gonna take forever. There we go. It takes its sweet time. Alright, where to go next? I've kind of got the clock circuit built out. How can I... I'll set the footprints on these, I guess. Jesus. Give it our TO92 wide squat that we made. Oh shit. That's interesting. And 1, 2, and 3. I guess that's fine because I wired it up like that. It'll be fine. Doesn't matter what it numbers. I've got it wired up properly. What do we do? Print assignment tool. Take that. Copy. I don't know how important this is, but I imagine it is. Need to come back there and double check these and kind of reorganize them as well. I feel like it's kind of a mess. Huh. And I still don't know what these circuits are doing. I know this is kind of our clock circuit. It's sort of like a bistable flip-flop, sort of, I guess. These other bits and pieces, I'm not sure. And I still haven't even finished the schematic for the boost circuit, or I guess the transformer circuit. I kind of want to map this out in the PCB editor, or trace it out in the PCB editor, and then come back and redo this. Because I was doing this with my Krita technique, which is obviously subpar. So there's probably mistakes in here. And I'm hoping that if I do stuff in here, then I'll be able to go back and forth a little bit easier without making so many mistakes. So, and all that circuit that I was just showing is kind of this stuff up here, this whole power delivery section with this transformer. And that all leads into this group of transistors that switch the displays, the VFDs. And there's a lot of transistors on this board that are doing stuff. Let's go ahead and I guess we could do this. I think this is the VSS reel. Or I kind of want to mess with the jumper list and the PIO programs. The boredom is growing. I want to get this thing working, but I don't know enough about it yet to troubleshoot it. I think the clock circuit isn't working. I was probing the clock circuit with the scope and was not seeing clock-like activity. The datasheet says that it should be pretty obvious clock signals. So we should be seeing on the external clock frequency of 250 kilohertz, which I didn't see any kilohertz, no frequency whatsoever. It's just solid on. But maybe I'm missing something about the calculator. Maybe it's like not turning on that clock circuit somehow. What is ref? I'm not sure if I should be changing this reference designator. Yeah, I thought it was supposed to... I guess it's to be silk screened. That the value would be pulled from the reference designator, right? I'm not sure. 'Cause I wonder if there's like a way for me to come in here and basically say, okay, yeah, this is resistor 2, right? So I could be like, this is R2. And then when I update it, it'll pull the value for R2 as well. Oh, weird. I guess that would be R5 or 2, 3, 4. Oops. had two names. Why you do that? Oh well, whatever. RN resistor network. I got it right. Okay, cool. Okay, standards. 2, 3, 4. I wonder if that's a bad idea. I feel like it's supposed to... I feel like it should be the other way around. Like, I update the schematic and it labels the parts? I don't know. Wow, this is like when I compile code. 39 errors, 17 warnings, ship it. Yeah, I have all the footprints pre-assigned in the schematic. That's what it feels like. It feels like I should go in there and set all the footprints. I don't know if it seems right though to set the reference value in here, so like changing the designator to like R2, because in the schematic this is R2. Where'd he go? He was over here. Now he's gone. But you know what I mean? I'll like label this one R2, R3, blah 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 blah. Yeah, exactly. The same on both sides. That's what it feels like to me. So okay, it's nice to have confirmation on that. I'm not just kind of like blindly doing things that are gonna take hours of work to undo later. Yeah, because that's what it feels like, that there's a couple things between like the schematic editor and the PCB editor that are linked or shared with like reference variables. And if you keep those the same, then it should be able to just like cross do everything or whatever. Need to rename these. Actually, what I want to do... Okay, so this is all wrong. I know that's wrong. Delete that. Transistors Q. Okay. I could come through and rename these. I don't want to just delete all this and come back through and redo it, but I feel like that's a waste of effort. I don't know. Kind of is, kind of isn't. How about I go through and place the new stuff in the PCB editor. Then I come through and I rename all this stuff. So this is supposed to be R1. This the 4.7K. 2, 3, 4. So this is 5. I think it's trickier because it's schematic does not line up with the physical layout of the board, obviously. So this is R1, R5. It's a 4.7K. That's also 4.7K. R2 is a 4.7. Okay, so that makes more sense. Ah, what are you saving now? Typing. I don't know. I don't really need to rename it. They do conflict, but... There we go, R7. Okay, so now there shouldn't be any conflicts. These should all still be named 1 through 6. Okay, cool. That's like a hold my beer kind of move. Rename everything, right? Okay, and these should all be Q something another. When I go through and figure out what part they actually are. Like these I can rename. I made custom symbols for these, I guess. That's right, I made custom symbols for these, and these were after I made, or before I made the custom symbols, so those are all gonna be Q something another. Okay. does it label Schottky diodes with? Which is D. Yep. Do that again. B1, 2, 3, 4. Okay. All right, nice. Oh, here, let's change this one too. So C1 connects to that R3. R3 and R2. Okay. So this is C1. It's E2. 5. Oops. Oh, where's the symbol properties? Whatever. I just pull them out and stick them in with a regular old generic NPN or whatever. Doesn't matter. GG, okay. Okay, I'm gonna save this. I think I'm gonna take a quick break. And then I come back, I want to mess around with some PIO programs with the Raspberry Pi 2040. Write some weird assembly. See if we can get some code set up to do some glitching. Make our own glitching utilities. So I'll give you guys visual on the breadboard if you want to play around with that. I'm AFK. Alright, be right back. Yo, what up? I'm back. April Fool's, sucker. Alright, so I want to mess around with, this code. Yeah, there's some stuff that I haven't added to the allow list for usage, depending on what it does. Most of the basic stuff is there. I have no idea what that does. I guess it's like changing the terminal color. But anyway, let me get this thing updated, the jumper list, as Kevin did some changes. He put some changes in for me. Sorry, chat. I'm gonna have to disconnect you. Merp, merp. Does it not have an update? Or what? No, I don't want Chromium as my default browser. Okie dokie. Is there an update button in here? Maybe, maybe not. Is this the registry? Added anything new? Nope. Oh, he added the 555 thing. What does that do? Ooh, is this where I can enable the PIO? Like RP2, right? Or something? I don't know. Let's see. Search Yahoo. Ugh. Let's see. Where's the PIO language? It's been a minute since I messed with this. So you'll have to forgive me while I catch myself back up. No? Program IO. Oh. Chapter 3 PIO. So there's like 6 state machines left. That's crazy. Okay. I just need one. I think. Alright, let's just go over it real quick and refresh ourselves. So we've got PIO programs, got 9 instructions: jump, wait, in, out, push, pull, move, IRQ, and set. And you just define them text-wise. We can use PIO-ASM to compile and test our PIO programs. Alright, we've got our registers. Output shift register. Holds and shifts output data between TX and FIO. 132 bits at a time. Okay. You do 32 bits every single clock cycle if the buffer stays filled. Yeah, our scratch registers, these are going to be like our variables. Yeah, and so these, and let me get the, may not even need to like do a whole bunch of like PIO coding ourselves because, let's see, E2040 glitcher. There's this, which comes with some PIO programs that we can utilize ourselves. So we can just tear these apart, kind of inspect them, figure out how they work. This one's called glitch. What is this one? Glitch side. Glitch falling. Low. We need to like look at the Python and see what it's doing. Which types of glitches those are. I just want to do like start off with like a real simple one. And, like kind of just pull a power line low, like pull VCC low or something. Glitch low might be what we're looking for. What's this do? Wrap target, this is kind of like a label to jump to, like a go-to label. This is the name of our program, so what we're going to do is we're going to pull a block, which I guess is block. I don't know. Then we're going to shift out 32 bits. Full block. Out 32 from the Y register. Huh, okay. I'm not too sure how this is working. So blocking pull, the FIFO's empty. Oh, okay. So it's stalling. Output level and direction of up to 32 GPIOs. That's driving the pin high. I guess setting pin 0 is going to drive it low. So is it just filling the buffer with zeros? Or because the buffer gets filled with zeros? I mean, I guess we can just hijack this and test it, right? See if we can call it. This is the one that I want to study. So, let me... Wait 0, pin 0, what's that do? Probably more stalling. Wait instructions condition is not yet met. Does that stall until you get a 0 on pin 0 and this stalls until you get a 1 on pin 0? PIO instructions execute 1 clock cycle. Okay, micro Python. I think there's a way that you can call it, hold on. How did I do this? I know this is a circuit pi. But I think you can just define, at least what I was doing is I was defining the PIO programs, and then when I came in here, oh, see, I was using the symbol. Okay, so is there something like that with MicroPython? Yeah, so I think I could do this. I can give it a program. Assemble a single PIO instruction. Usually I want to use ASM_PIO. And well, we have some stuff to play around with. So let's come over here. Let's just use our existing glitch test one. Right. Let me see, what was he saying about... Let's see how he got this added. I don't know if I just have to import the module or what. Oh, he's got a firmware for it. Okay. Alright, 1 second. Let me get this over here onto this system. 1 moment. I'll walk over to my other machine. Guess I probably could have done this earlier, huh? Okie dokie. Plugged in. Wow, the cursed 4-dimensional USB port. Hello, kitty cat. Yes, you're super cute. What is it? You? Oh no, I need to reboot it for the, I don't know if it'll let me do that from here. That's okay. I'll just do this. All right, there we go. Now let's see. Probably ACM4, right? Yeah. Cool. And what, can I import RP2 now? Wait. And I'm gonna save this. Let's do import RP2. Oops. And I think what I want to do, let me check. I should be able to assemble the program. Is it gonna make me describe it or translate it into this weird Python-like language? In MicroPython, PIO assembly routines are written as Python functions with the decorator, blah, 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 blah. Use Python syntax. Such routines support standard Python variables and arithmetic. As following custom functions that include PIO instructions. Also, hey Kevin, if you're listening, I think the UF2 disk label says RP2030. Or 2350, sorry, instead of the 2040, right? This has a 2040 in it? I can't remember. Or I could be wrong. Hello, yes, kitty. Yeah, so we may need to translate our IO programs into this kind of language. Okay, what is the best way to do that? I mean, I could just rewrite it. Rewriting it would not be that difficult. I'm not sure what this functionality is doing, though. Why it's doing pull block and then out to X. It's shifting, what, 32 bits out to X. Is that just shifting 32 zeros into X? And then this is pulling 32 more zeros. What does pull block do? What is that? There was like some sort of stalling, right? Pull. Oops. What about pull block? Give me anything? No. Oh god. Yeah, take me back. I guess it's just a blocking pull. Some peripherals should halt when no data is available and pick it up as it comes in. Others should clock continuously, and it's better to output placeholder or repeated data than to stop clocking. It can be achieved with the block parameter. Okay, so it just halts when no data is available. Any non-blocking pull on a empty FIFO has an effective smooth output shift register X. Program can either preload scratch register X with a suitable default or execute move X or after each pull no block. So the last valid FIFO word will be recycled. If you do pull no block, it just recycles and does the last contents of the buffer. Pull if empty. Blah, 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 blah. That's the block bit by default. If the block bit is not set, the push does not stall on a full RX FIFO. Continuing immediately to the next instruction. FIFO state and contents are unchanged when this happens. So I guess there isn't really any reason to like wait, I was reading push. I guess it's the same, right? When auto pull is enabled, any pull instruction is a no op when the OSR is full, so the pull. Okay, whatever. I'm getting a little too deep into the weeds. And then let's look at the out instruction. shift bit count bits out of the output shift register, write those bits to destination, and destination would be like X, comma, and then 32. So this one is, yeah, so it's pulling blocking, or it's doing a blocking pull, and then it shifts 32 bits of that data that it pulled into the OSR out to X, does the same, outputs it to Y. And I think this is waiting until pin 0 is 0, this waits until pin 0 is 1. And this is a delay. X minus minus, I think this is just like kind of initiating the delay. Kind of jumps a couple times, or jumps one time. How many times is that? What's the minus minus do? Here's our jump. Scratch X non-zero prior to decrement. Delay cycles on a jump always take effect whether a condition is true or false, and they take place after condition is evaluated. Oh, okay, so scratch X non-zero prior to decrement. Oh, is that how long it is? Is that how long it's gonna stay low? And then delay 2 does the same thing. That pins 1. I don't know what are pins. I guess set, right? Here, set. Write immediate value to value data to destination. Destination can be pins, scratch register, X or Y. And so what are pins? Obviously that's pins, but what does that mean? What does it mean? Full flow. And drive pin high and then delay for 1 cycle. That's what this does, right? Drive pin low. Okay. So this is going to I can't tell if it's going to bounce it back and forth between high and low. I wouldn't think that it is. It's gonna... Oh, see, it gets to this first one. And then what it does is it jumps to delay 1. Executes this. Oh, wait. Oh, I'm not sure. What we can do is we'll just try it out, I guess. See what it does. Maybe the code that I took it from explains to me how this works. Void glitch low program, PIO. Length minimum, length max, delay, the trigger. Okay, none of that's really helpful. I'm curious how this is actually working. Trigger glitch, get init command. So here's where it actually runs the glitch low. What's the difference between that and glitch and normal? Yeah, just glitch program, right? What does this one do? Okay, yeah, so get... Oh, look, it's got comments. Wow, isn't that nice? I could have just scrolled up and read that. We can confirm some things. Get delay duration. Okay, so that makes sense. Load it into X. Do the same thing for delay 2. Load it into Y. Wait for NGPIO to go low. Okay. And then high. Oh, okay, yeah, pin 0. Yeah, so it's waiting for pin 0 to go low, and then waits for it to go high. Oh, I guess that's the trigger. Yeah, NGPIO to go low. Which we will want at some point. Alright, and so this jumps to delay 1 for 32 cycles. So X plus 1 cycle, well, delay for X plus 1 cycles. Oh, gotcha. You pass a 32-bit number in there. And then I guess it just keeps doing that. If we had some other instructions before this label, those would get executed and then it would jump again and it would kind of just be a loop. Public set 1, set pins, turn out GPIO high. Delay. Turn GPIO low. Alright, and I guess that is, that's controlling the MOSFET. Or maybe this is actually doing the, no, this is probably controlling the MOSFET. Generally, you want a MOSFET to do this anyway. Alright. Hey, I slopped that JPEG. I don't get it. Like, what's the point? Like, if you're gonna use, like, a slop image like this, just go take a photo of a rock. Like, I don't know, take a photo of some junk that you have on your desk. Like, it's better than just, like, wasting electricity to get a generated photo of a dog slobbering on a microchip, I guess. I don't know. I guess that's my rant. AI has its purposes. You don't need to, like, be using it for all sorts of stupid stuff. Okie dokie. So this is the actual Python code that launches the glitching commands, or sends the glitching commands, I'm guessing, over serial. Yeah. ETY right. Glitch prepare. Just to get an idea of how this is working. Okay. So realistically, what we need to do is we need to translate real generic, like, delay for however much time, and then trigger set our pins to high, our output pin to high. Okay. Oh man, this just makes me want to do regex. Oh, I could translate this with regex. I could do it by hand and it would take 1 second. Because I have to convert it into this stupid language. Can I just bring this in, the Adafruit PIO ASM? So another thing is an import Adafruit. Wow. Nope, of course not. I don't know why. I guess it's not really that much effort to translate it. I just feel like writing it in the native assembly language that's closest to how you'd write it for, I guess, C to interpret it is better, but who cares? That's not what I need over there. This is what I need. Bruh. Oh. Jeez. What's the decorator? Hello? Oh. Python function written with the decorator. And what do we got? If it's not specified, it's automatically added at the end of the PIO routine. Finishes and wraps around wrap target. Execute continues after program wrapping. By default, this is the start. Okay, so we don't need to specify those. Let's do our pull, right? So we want to pull, pull block. Oops. Oh, I'm sorry. It's like I haven't written Python in 2 days. Alright. What are you whining about? Undefined name pool? Yeah, I know. Because you're stupid. Oh, it's gonna annoy me so bad. Oh, give me advanced mode. Connect web REPL. Whatever. Okay, so you've got a pull block. Let's shift that out. Oops, shift that out to X32. Then we're gonna do Y32. Yeah, our destination bit count. Output shift register to destination. Okay. And then we want to wait until pin is 0. Is it pin or pins? We have a delay modifier? No. Modifier which can be applied to any instruction and specifies how many cycles to delay after the instruction executes. 0 to 31 max value reduces side set pins. I wonder if we could just specify that as our delay. We can do like delay equals n. We want to waiting until pin 0 pins. What our pins refers to. Following custom functions that encode PIO instructions and direct the assembler. Section 3.4. Good. Goodness gracious. What is wrong with you? What is section 3.4? Whoop, 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 whoop. Oh, the instruction sets. Duh. Okay. Is this entertaining for you guys? Watch me bumble through some assembly. Okay, so the wait instruction waits for pin to go 0. What is pin though? Is it supposed to be pins? Oh, pin is relative to state machine's in base argument. Or an IRQ, GPIO, absolute pin. Okay. That makes sense. So it waits for the input pin to go 0. And then we can wait for it to go high. And then we want to jump, right? Label to jump to unconditionally. Jump and then condition label. We need a label. Label, label, label. Let's look at what they've got for us for examples. Like if we want to label yeah, so they don't have any nesting. That's kind of annoying. Makes it visually hard to... I really like this syntax over the writing it as Python syntax. That's okay. Label, this is going to be delay. I mean, I'm not creative enough to come up with anything. Delay 1, delay 2. Oh, so X decrement. Proof register is non-zero and do post decrement. And do post decrement. Okay. So it needs to be. Condition is. X decrement. Decrement. Alright, save that to the device. Actually, I want to, use this. Bruh. Oh, is that's in the... Like, what the hell? okay. I guess this is the Raspberry Pi 2 module. All right, that's cool. Now we gotta set our pins, duh. So let's do set pins 0. And so I'm just gonna set pins, right? Yep. Right, so how to actually execute and test the call pi2.asm PIO assembly PIO program. Returns a state machine, right? So create the state machine with the program. IO.outload. Okay, so that's its init state. I feel like this is going to throw an error. Because this is where the state machine U. Let's see, frequency 1000. That base pen. It starts yeah, return to state machine object. RQ handler to print the millisecond timestamp. Interesting, what is that? This thing, IRQ? An interrupt, but what does that do? There, clear an IRQ flag. This instruction takes two forms, IRQ index. Relative IRQ indices add to the state machine ID, blah, 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 blah. What does that do, though? Oh, that's IRQ handler to print the millisecond timestamp. Milliseconds, so it's got a little lambda. Okay. Interesting, I didn't know that before. Yeah, so that's another fun thing about these little PIO state machines is you got to count each instruction as a cycle. So you can see right here, you're counting 1 plus 1 plus 6 plus 32. So this is one instruction, this is one instruction. It does one instruction and then sleeps for 5. So that's 6 instructions. So we're at, 8 clock cycles. And I guess the labels don't take a clock cycle? And then it is a not for 30 instructions. Oh, and then it adds this one, 30 plus 1. Gotcha. Delay high, jump to delay high. And then it repeats that. Oh, wait a minute. It's this label and then goes back and forth for 29 steps? I don't know, but you get the idea. You're gonna figure out how many cycles your instructions take. If you're being like real precise with your timing, which we might have to be. Oops. I mean, I think that does what it's supposed to do. You're just gonna wire it up to something. Here, let me get my breadboard and stuff going. Get a little circuit going, I think. Or an LED. What is this? 3300K resistor. Oh, 1100. 0, 0. Oh, 110 ohm resistor. Oh. Yeah, I can't read those with my eyes. So, which one were we using? I think it was this one. We were using, a different guy. Oh, I've still got it up here. Okay. Wrong breadboard. Actually, you know what? I wanted to test it with directly on the jumperless. Maybe a bad idea, but who knows? So then what I want to do is test... Oh shit, what's the pinout on this thing? I can never remember this crap. BU211? Or BUZ11? Yeah, the BUZ11. I don't even know if this is a suitable MOSFET for this. I'm not a robot. 9196. So our gate threshold voltage for on is typically 3 volts, right? 1 milliamp. Switching, turn on rise time. Maybe. Because we're going to be using it in switched mode. So off characteristics, typical. Okie dokie. Oh, what's the pinout? So TO220, 123. And one is the gate. Yeah. Gate drain source. Right? Okay. Put this sucker on 50. Actually, I want to disconnect. Let's see. So our MOSFET's on 50, 51, and 52. We can do, what is it, DGS, DG. Almost MOSFET. Actually, this probably all needs to be under setup, right? Whatever, I'll move it around later once I actually know that it's doing stuff. So our drain gate source. Got that wrong, so it's GDS. GDS is our MOSFET. So then we want to power our board, right? And then we want to have one wire going to the source. Drain gate source. That's going to be 52. One wire is going to that. And then we've got these guys. Oh, let me flip that around. This is going to power this breadboard with our jumperless. And let's see, we're going to need a ground connection, right? Okay, so now our bulb is on. Okay. So I hope you guys can make this out. We're gonna get our scope on. And I kind of put a different LED in there. Or a different resistor. That sucker is bright. Real quick, get that. Did I just tell me all of them? No. Right. Get DAC. Or I in range. Is it 3? There we go. Or is it 4? Is there a get DAX command? Am I just missing out on the get DAX command or something? No. Okay, check this out. Get the big brain up in here. Def get. So we've got 4.2 volts on all these suckers. Get DAC. One's 4.2 volts. I think that's enough, right? For the it said it was 3. Turn on. Max is 4. Okay, so maybe we don't turn it on with 4. So we could set up at I don't know, let's do 4.2, and then let's do 8 threshold, so VGS. Typical is 3 volts. So we can set DAC. What's the channels for the names and constants? DAC 0. No. I always forget these two. Top rail is 2, bottom rail is 3. So the fourth DAC is bottom rail. Third DAC is top rail. Oops. Accidentally disconnect my keyboard. So I'm just writing some of this function real quick to do the testing for us. So we want to connect our MOSFET gate to the trigger crossbar, connect MOSFET drain to D, source to input crossbar. So let's go ahead and connect. Okay, so that's going to be to our trigger, which is, I guess, let's just do, I don't know, 56 or something, or 30, we'll do 30. Then I'll wire that out to something. Connect our gate to 30. Connect our drain to D. Oh, I need to put jump release in front of these. Did I do that over here too? Probably. Get all decks. Then we gotta connect our source to the input crossbar, right? Okay, connect source to... Shit, what is that? So this is our trigger. And our current is gonna be flowing until... we trigger it? Injection. That's right, the drain goes to ground, and then the source goes to that pin. I guess we don't really have to connect that to anything, do we? Because we've got that wired into... Okay. So you wire the MOSFET source crossbar to the device under test voltage, which is going to be this little orange one right here. So this is going to be the VCC line. This is where our voltage is coming into the LED. And so theoretically, what I can do is I can connect... Here, let's move these to the setup. That'll do that, and this will be the trigger crossbar. It's gonna be 30. That'll connect 50 to 30. Okay, I guess I just need to make like I don't know, it's just boring Python. Is that what you want, MOSFET? Def init. How about we just do this? Gate, drain, source. That way if you have some weird fucked up MOSFET or something that has like, I don't know, bullshit ass pins. We're gonna set our DAC. And then let's do this shit too. Right here. Then gate drain, and then our source. Yeah, I think that's good. This is going to be self gate, self drain. Let's see. I don't know, whatever. That's just getting too fancy with it. I'll leave it at that. And then what we can do is set up, we want to ignore. Actually want that, right? Ignore that. What else do we need? That's it, just BGS is 3. Then I guess if we want to, we can have like Okay, well what we want to do is we want to run this PIO program against it. Let's do a little bit more. We've got, I think, what we need to run that against it. We can test with let's just test it really quick. Connect mos dot gate to, where's it? DAC equals DAC 0. And then we can copy that and we will just disconnect it. Alright, so that should save it, and maybe it'll do something when it saves it. Probably not, but let's get our testing stuff hooked up over here. Get our test lead. This is going to be right here. Like that doohickey up. Let's get this guy out of here. We're gonna swap that wire for the green one just to be consistent. All right, and let's ground this to our circuit. There we go. All right, and then what I want to do, let's check what the scope is up to. We're set to 2 volts. Says our max is 3 volts right now that it's reading. That's powering this bulb. Wonder where that is. It should be 4 volts. Oh, I guess that's because that's what it's being knocked down to from the resistor. Okay. Then if I do switch test, what's it do? Switch test isn't defined. Oh, okay. From glitch test, glitch t, glitch test, import switch. Yo, glitch low wait takes 4 position arguments, but 3 arguments? What the? What are you talking about? Oh, yeah, you're right. Okay. Okay, so we are waiting for a 0. ILO on a pin or IRQ line. Source and index for source? What the fuck is index for source? Oh. Oh, pin relative to state machine's in base argument. So we give it an in base pin of like say 10, and then if this is 0, it's gonna be pin 10. If it was like 1, it'd be pin 11, 12, 13, 14, and so on and so on. I don't have to do that for set, right? Destination and data. Pins. Pins. Okay. Back 0 isn't defined. Yeah, you're right. Back 0 is not defined. Okay, listen here, punk. Oh. So I guess it turned it off. Oh, we gotta do it again, right? Make sure that sucker ain't getting hot. Okay. I can see the bulb flashing, so that's cool. Bring our trigger down about right here. No, wait. That's max 640 volts. What's our trigger set to? Menu. Edge. Up or down. Let's set it to normal. We catch that. Yeah, so if we... And this is kind of the... This is without the PIO. So we can see this leading edge where it turns it on for a moment is... We can... Let's see. The frequency... Or sorry, the width. Measure that. So the width is 97 microseconds, which is fast. That's fast, but not fast enough for device glitching. That's enough to turn the device off and reboot it. Let's go ahead and switch our... I'm gonna go back to auto mode. We need to... Let's toggle this gate real quick. Wait, which one's which? Oh shit. Gate drain source. So connect 50 to back 0. No? Oh, gate was getting... Oh, gotcha. Interesting. Not reading my own code. Okay, so that reconnects it to that, which means that I can stick this wire. And we can, say, knock it down over here, I think. Okay. Alright, why is this not working now? It says that I'm getting 1 volt? Hmm. Re-import our code. Oh, that's actually pretty quick. What is that? How fast is that? Wow. Normal. How do I change the slope? So that sets the DAC to the VGS source voltage, or voltage for the gate. Why is it off though? I feel like it shouldn't be off right now. Do I have that around, or like backwards? The drain needs to be going to Does it go drain to source? Drain to source or source to drain? That's source to drain, right? That's the only thing that makes sense to me. I don't know why it would be drain to source. Wow, you can drain 134 amps? This thing might be a little too big. Is it just because it's like, I don't know. Maybe I need to move this to the other side? No? 2.8 volts now? And then trigger this. Does it cut off? No. Because it's already past the bulb. Can I restart you again? Let's see. Yes, I do, because those are not backwards. Or hold on. Let's see. Disconnect. 50, -1. 1. -1. And then let's import. Yeah, I gotta. Dang. Let's restart this sucker. Alright, so now it's kind of wired backwards, and if I do... Wait. No. I didn't need to do that. The gate goes to ground. No. Man. D. Wait, the drain's in the middle? Yes, gate drain. Source. Okay, so let's try setting the source. Next, 50 is going to be, actually I don't know why I disconnected that one. 50 is going to go to 30. Right, and then connect 51. Or 52. 52 is going to go to j.gnd. Or just gnd, right? Because they're not in there. And then we've got our device under test, VCC on the middle pin on the drain. Then it should go bloop. Jump that over to ground, right? So then if we connect stack 0 to 30, and then we disconnect stack 0 from 30. What does that yield for us? It turns it off. Okay. Do I need to connect it back to DAC 30 again? Bruh. Okay, what if I go connect 30 to GND? There we go. Okay. What about if I disconnect? Disconnect 30 from GND and connect it to DAC. And then connect 30 to GND. Yeah, I think Kevin was saying that won't work because it internally checks to make sure that you're not routing like a DAC to ground or something. Disconnect DAC 30. Then it comes back on because it is internally connected to ground. Interesting. So if we just connect, let's see, connect 30 to GND, and then we go back and we do our flippy dippy, right? Where we connect it to the DAC and then disconnect it to the DAC, it should pulse. Right? I don't know, we may need the scope. Yeah, I'm not seeing anything. So I think you gotta go. You can't have it like connected to the ground. Oops. Connect. And then if we do this again. Oh no, wait, I was doing the wrong thing, wasn't I? No. That turns it off, and then if we connect it to the ground, turns back on. All right, so what we need to do is we need to run our PIO program on pin 30, the one that we are flipping right now. That's our trigger pin. So we need to bring that high. I may need to reverse this where it goes high and then goes low. For my particular MOSFET setup or something. Yeah, so let's try to get the PIO to work. So how do we load that into a thing? We've got to come down here to this one, or Pi 2 ASM PIO. Yeah, and I guess it doesn't matter which one you plug it into, whether it's the gate drain or the source. Okay, and then we'll do RP2, what is it? ASM PIO. That's where it gets pretty weird. Oh, is it PIO glitch low? Zero comma blink 1 hertz. Oh, that's the state machine that we get to run it on. What was it? Mention which machines we have to work with. Oh shit, okay. So it looks like we can work with PIO 0 and PIO 1, and then the state machines 1, 2, and 3 on both of those. But let's just do 3 on PIO 0. See what that does for us. I guess you don't really specify which state machine, right? Kind of just make them and then kill them, so that's going to be PIO core 0, I think. It doesn't tell me what the fuck this is. What is that? I should do that, see what it does. Uh-huh. Takes 0 positional arguments. Doing this wrong? What the? Well, obviously I'm doing it wrong, but... Oh, because that's... it's state machine, not... Good boy. Oh, I probably want to set... what is it? Base equals pin... Oh, wait. This pin... GPIO pins, right? What GPIO pins do we have? I guess we could do 8? GPIO 8? That works. At base. A GPIO 8. That may be defined with the machine library or interface, so it may just work. Sure. Oh, we need to set the SM active, right? State machine claimed by external resource. Okay. Wait, we need to connect GPIO 8 to 30, right? Oh, you know, we could probably just come up here and connect this to... EP is going to be... GPIO 8. GPIO 8. That connects the trigger pin to self.tp. Okay. Hello, kitty. Hello? Kitty cats are hungry. Let's see. So that's funny. I don't see anything from my cats all day long until they're hungry, and then they both show up. Okay, so let's reload this. Ice has been lost, blah blah blah. Connect. Hey. Be nice. Magnesium 7? No? Okay. Oh, it's gonna be. It doesn't like that. Okay. That's interesting. Huh. Seems to not be responded. Alright. Let's see. Huh. Oh, I wonder if that borked up the OLED because the GPIO or something. State machine claim. Oh. Yeah. Oops. Okay, save those changes. That'll connect it to DAC. Okay. Okay, so has it got all of these connected to wow, how did that happen? $50, $51, $52. Oh, how long have we been streaming? Yeah, I think I've been going for a bit. My cats are hungry. Gotta go to the bathroom again, so I think this is a good stopping point. Definitely want to mess with this some more and test this out, because I think now that we can get like a PIO program running, I think that's our shot to getting faster switching, so I can control the device under test a little bit quicker and get faster switching speeds. We can do a crowbar on the VCC of whatever we're testing and maybe cause it to do something weird. So yeah, thanks for watching. And yeah, if you guys want, there's a Discord you can join. I've got other videos on the channel, other VODs. You're welcome to check those out. But yeah, thanks for watching. I will see you guys later. Bye!